Hello, welcome back to Algebra. This is your EOC bell work. Please go ahead and pause your video and solve this problem. And then when you're finished, turn it back on and I will go over it with you. All right, so let's go ahead and go over this. This is comparing two different plans for her to get paid for babysitting. So, two payment plans. The first one, she's paid $5 per hour, period. $5 per hour, it doesn't change. That makes it a linear equation or a linear function. This is plan one. But on the second plan, she's paid 25 cents for 1 hour. It doubles to 50 cents, doubles to $1, and so on. So it is exponential growth. So you can see that it's going to very quickly get to be a lot of money if she continues to work for a lot of hours. So they're asking, what is the difference? The difference is one is a linear function and one is exponential. Next, they're asking, which plan should she choose if she's going to babysit for 4 hours? So 4 hours, well, you can see right here, exponential would only pay $2 because she hasn't gotten to the point where it's doubled so much yet. But linear, she'll get paid $20. So right here you can see the difference between the two payment plans. And so for 4 hours, she should definitely choose plan one. And so then they ask us to describe when Sarah should use plan two. So you can see that plan one pays more all through this time period. 6 hours pays more, 7 hours pays more. When we get to 8 hours, a little past 8 hours, they get paid the same. But then after this 8 hours, 9 hours, my line's not straight, but after 9 hours and 10 hours and so on, then plan two is going to make a lot more money. So she should use plan two if she's going to babysit more than 8 hours. Up to 8 hours, they get paid at 8 hours, they'll get paid the same. Below 8 hours, plan one, and above 8 hours, plan two. All right, so that was our first question on today's bell work. Now pause and do question 2, and then come back when you're finished, and I will go over the answers with you. All right, so I'm going to go ahead and answer the questions here. It is comparing, again, just like we did in the first one, two different graphs, two different functions that represent the attendance in two different parks. So here's Park A, it's a quadratic. And then this is Park B. Park B is exponential. You see the x is an exponent. And so in both of these, the x represents the number of years since it opens, and y represents how many people have attended in hundreds. So we have a chart that's showing the results of this function and this function here. So the question is, in which year does Park A have the greater attendance? Well, right here, they're kind of the same. And then you can see that starting about year 4, Park A is higher. Park 4, 5, 6, 7, 8, maybe at 8, it's hard to tell because we don't have graph here, but it looks like right around 8, then they even out, and then Park B takes off. So Park A has more attendance from year 3 to year 8. And then in which years does Park B have the greater attendance? Well, Park B has greater attendance at 0. At year 1, you can see here better on the graph than you can here. Year 1, A has higher attendance. So this is year A, Park A, So Park A has a higher attendance at 0, which doesn't really make sense because if the park's not open yet, you're not going to have attendance. It's just a quadratic. And so it really has the most attendance between those years. Park B has greater attendance after 8 years. And we said that the reason they are different is because one is a quadratic, so you're only going to take x and square it, whereas Park B is exponential, and exponential is going to keep on multiplying by 1.8, and so it's going to get larger and larger and larger very quickly. If the trend continue, will Park A's attendance ever surpass Park B? No, because Park A is going to keep going at the same steady rate. Park B is always going to have a higher amount no matter how far you go because of the nature of the two functions. An exponential function gets very large, and whereas this one does too, but not at the same rate as the exponential function. All right, so that is your bell work for today. If you have any questions, let me know.